All right, welcome everyone. Today is Wednesday, the 15th of July, 2026, and this is the Cluster API office hours. Cluster API is a sub-project of Kubernetes SIGs, and as such, we follow their meeting guidelines, which can basically be summarized as please be excellent to each other. And if you'd like to talk, please raise your hand and I will call on you. So at the beginning of our meetings, we like to take a little chance for people to introduce themselves if they would like to. So I'll be quiet for a few seconds here. And if you'd like to introduce yourself to the community, please feel free to unmute and say hello. Okay, I guess there's only five of us in here, and we've probably seen each other's faces before. So let's move on to our regular agenda. Open proposal readouts. Do we have any updates on either one of these? I guess the code organization one, Stefan, did you have a
Yeah,
topic?
you can delete it. It's merged.
Okay. Is it merged already?
Yeah, we set it last connected until today, so I merged it today.
Nice. Good to hear. All right. Okay. I guess no one's here to talk about the independent worker topology.
It's on the agenda
Uh,
as well, so we
Oh,
can talk about it.
Actually, we have an update about that. So it's on the agenda today.
okay, great. Yeah. I missed that. Sorry. Okay, cool. Well, we'll just keep going through the discussion topics then. So yeah, Stefan, you're up first here.
Yeah, just a heads up for um, other providers, I guess, and people running stuff in Brow. They merged some change to the Kubekins image, which a lot of people are using, and that is getting auto-bumped. And the change they did led to some change in C groups, I don't know what. And the impact is basically that if you run, so I'll just mention a specific impact that we had. So in core copy, we run one kind bootstrap cluster, and then we run a bunch of controllers inside that, and then we create a bunch of other kind clusters. And in some way, the C group usage accounting now changed in a way that a bunch of our controllers hit OM issues. Example, one test run, bootstrap provider, 600 restarts, 600 OM kills in 1.5 hours. So you cannot get an end-to-end test job green of that. What we did is basically just, we chatted with test infra, SIG infra, and they helped us pretty quickly. But basically, we checked the Grafana dashboard, where you can see how much memory usage your jobs have, and then we just bumped the limits. Yeah, so just if you also have some issues with either end-to-end jobs failing entirely, or also maybe they're getting a bit awkwardly flaky, and you look a little bit closer and then you see that your controllers have a bunch of restarts, or you have a bunch of, I cannot communicate with a webhook because it's down issues. You might want to think about that change and also look at your resource usage and bump it a little bit. I'm going to add a link to the Grafana dashboard in a second to the agenda. So you know where to look up the usage. So Grafana dashboard. Okay, so that's basically part one. And part two is, while we were talking with them, they also mentioned that there's a Kubekins end-to-end V2 image and people should migrate to it. We're planning to do this in copy soonish. Yesterday it still worked, but I have the same problem that you have. So we're going to do this like in the next few weeks or something. First, wait until CI is stable, then I guess move a few branches and then move everything or something. They're basically saying that for copy shouldn't make a difference because there's just, I don't know, one Python script less and some other stuff. It should be all in that issue. I didn't read it yet, but yeah. So just FYI, please migrate. They're asking for migration. I think sooner or later. I mean, the last sentence in that issue. It didn't happen yet, but they wanted to basically block additions of new jobs that are using the old image and that kind of stuff. So I think sooner or later they will be announce this more broadly and then enforce it sooner or later. That's my expectation.
Cool. Looks like Matt's got a question, perhaps.
Yeah, so these two things aren't related. You're just saying that
No,
they
it's
okay.
just It's just while we were reporting one issue, we also got a response like, hey, bump the limits and also migrate to this other image. But
Gotcha.
as
Yeah.
far as I can tell, there's no correlation. Also, basically, they had the same C group change in both. So the story is slightly more complicated. So actually, they made a first change to the C group stuff that broke some stuff. Then they rolled it back. Then they made another change, tested this to some kind jobs. Everything was green. But the new image basically now only breaks copy stuff. So that's why they didn't roll that one back. And basically, these changes in the C group stuff, they made them both in KubeKin's end-to-end and in KubeKin's end-to-end v2. And so both issues are orthogonal. You can fix the current issue without bumping to v2. It's just, yeah.
Gotcha.
It just mentioned it.
And do you think we should be proactive and go ahead and bump the resources, or wait until we actually see problems and then?
I think it doesn't hurt to look at the dashboard. I mean, I don't know why it's not working right now. Maybe check again like tomorrow and the day after and see if it works then. And if it doesn't work, report to testing ops that the dashboard doesn't work. But I think it doesn't hurt to take like a quick look at some periodics just to see like how close you are to the limit.
Sure. Yeah, I haven't seen any. I haven't seen any CAPC failures out of the ordinary, but
yeah, I think
maybe we will soon.
Yeah, what I can tell you is that in CAPI, end-to-end jobs that were only running one test case were still green. End-to-end jobs that were running basically everything with 3 Ginkgo nodes concurrently were all entirely red, with like at least 50% of the test runs failing in all of these. And I think one case was green somehow. And in CapV, the story, so in CAPI, what the special thing is in CAPI is, of course, that we run CapD and CapD runs additional kind cluster. In CapV, the experience was that we have some jobs that are also using something like CapD. They were also entirely red. And then we also had normal jobs that are only using one kind cluster and then basically vSphere. One of them was also entirely red. The other one was entirely green. So it's like a very mixed picture and maybe also just a little bit OM kills. So, I mean, on the other side, maybe it's nice chaos testing, right? If your jobs are still green, even if your controller gets killed like every few minutes or seconds, or depending on how it's going. But for us, it was too much. 600 kills was too much in 1.5 hours to get to a green run.
Okay, thanks.
Yeah, sure.
I like that chaos testing. Yeah, good call. All right. Any other questions or comments about either of the topics that Stefan has brought up here? Okay. I'm not seeing any other hands going up or anything. Anything else you wanted to add there, Stefan?
No, all good, thank you.
Okay. Move on to the next topic, which is mine. This should be a fairly easy one. I was trying to look through the cluster API book to see if I could figure this out, but I couldn't quite find it. So the background here is I'm working through a bug that is a cluster autoscaler issue that comes up in like cluster API bare metal. And the bare metal provider has a special case where they will put an error condition into the status conditions, and this is like during provisioning, but they don't go into a failed state, or they don't go into status phase failed or whatever, because they're still looking for an instance or something like that. They have a reason to put an error message there, but not be in a failed state. And the cluster autoscaler was like incorrectly detecting this, which is causing it to delete, bare metal machines as they're still in the process of being made. So I'm making some changes to KubeMark so that I can test this out more thoroughly. And KubeMark is a very simple provider, but I couldn't figure out like it's the responsibility of the provider. Like if I have a KubeMark machine and I have machine, and I'm going to put an error state, or I want to put that KubeMark machine into a failed state, is it my responsibility to add that information to the machine object as well? Like, do I need to say, here's my KubeMark machine. It has a reference to the machine object it came from. I need to update the machine object to say status failed and put the error message there. Is that the general assumption for providers? Does anyone know, I guess?
Should I start, Fabrizio, or do you want to tell the whole story?
A question first. where do you put the condition with the error? On the node, on the infra machine, on the
So it's coming through on the machine object is what it looks like. That's where
on
that's where the bare metal is putting it. Because like when the cluster autoscaler is getting the cluster autoscaler doesn't get the actual like, foo machine or whatever. It gets the machine object, and that's where it's pulling the error from.
so yeah, I'm trying to figure. So I think that a good answer here is that in cluster API we have this when you look at the machine, basically you have this idea of machine availability and machine readiness. Okay. Machine readiness, cluster API ships a default definition of readiness. Your infrastructure must be ready, your bootstrap must be, secret must be created, etc., etc. And then gives users the possibility to extend this idea of readiness or availability. This idea, so the most powerful way to do this is to use readiness gates. Basically, you can say, hey, if this machine has so for computing readiness, basically you have to look also at this condition. And those are the readiness gates. This is how we do express a readiness gate, but it's not. And basically, if you have a condition that fails, that goes into readiness gates, then the machine ready and the variable basically bubble up the error, and the error goes up the chain, up to the cluster. I don't know if this is exactly what we are asking with error propagation or responsibility, but that's how it works. So TLDR, copy takes care of computing ready, availability, and bubble them up the chain.
Okay. So if I have my foo machine type and I put an error message in there, then cluster API will say the machine will put the machine into a failed state, or
There's
No,
no failed state anymore.
sorry. This is what I try to figure it out at the beginning. So the full machine type is the infrastructure machine. What I talk about is the actual machine, the copy machines. Yeah.
right, the capping machine.
So a readiness gate only looks at condition on the machine itself.
Okay.
So if you put a condition on the bare metal machine, this cap is not aware of it.
Okay.
Unless you make this condition part of the bare metal ready condition.
Okay.
So copy is only looking at one condition from infra machine.
Okay. That makes sense. I'm trying to figure I guess based on what Stefan was saying, I'm just curious. Like
I'm wondering a bit what you're doing with that information in autoscaler, and if that
so we're trying to so like first of all, like, so is this still set or is this not used anymore? Phase. Like, can we use phase to determine if something has failed or not? Like here,
So
like
according,
So we dropped the concept of a machine being failed entirely. It does not exist anymore in alpha.
okay,
In
so
beta
like
2.
this is not like is this even being like is this even being utilized anymore then?
so according to the Kubernetes API, you should drop phase from objects because in Kubernetes, objects are not state machines.
Okay.
Okay,
So
but we had a discussion about this, and we sort of decided it is useful for the user to figure it out if a machine is provisioning, whatever, and so we decided to keep them in
right.
Cluster API.
But like, can we, like, I'll show like, I'll answer Stefan's question now, and then maybe we can come back to like, what should we be using? So, we accepted a patch to the cluster autoscaler, I think 2 releases ago or so. And in that patch, we were trying to solve a problem where, sorry, I got to find this code here. We were trying to solve a problem where when we look for the scalable resource, provider IDs, we want to be able to determine, we want to not give back machines that are in failed state. Like we should not be telling the cluster autoscaler about machines that are failed, right? That do not have a provider ID. And so originally we had some tests, we had previous code that was going in here and all it did was look for the provider ID and I think it looked for something else. And then when I think the V1 beta 2 stuff came out, we upgraded to look for a failure message.
Yeah, but that was basically deprecated with beta 2.
Right.
Failure message.
Oh, is it now like error message or something, or is it just gone?
No, it doesn't exist anymore. That concept does not exist anymore.
Okay, so this is totally wrong then.
With beta 2, yes.
Yeah. Like the bare metal thing I'm working with like is still falling through this logic for different reasons. But like it sounds like how should we be detecting a failed machine then from the cluster autoscaler perspective? Like if we look at a machine, how do we know that it's failed?
I think it's even more wrong than just looking at the wrong field. I think it's as wrong as the concept of a machine being failed does not exist anymore.
Okay. Yeah, that makes a big difference.
That's what I was trying to say.
Well, here's,
or maybe I missed something, but I think that's what you basically did, right?
How do we, like, is it still a concept that something could failed provisioning then? Like that you could have an instance out there that's running that never managed to become a node, and the machine is still there, and the user needs to like delete the machine or something.
Maybe what would be interesting to know is you said like you do not want that autoscaler sees failed machines. What impact does that have if it doesn't see the failed machines? Is it like going to upscale, downscale? Is it going to compute the node to pod thingy differently?
It thinks
what it's going to do with
what ends up happening. Okay, so the cluster autoscaler takes account of the nodes, and then it tries to look at the instances, right? And it says, okay, do you have instances that have not become nodes yet, which means they're still in the case of provisioning? At some point, the cluster autoscaler wants to say, okay, I'm going to give these nodes a certain timeout before I consider them to be failed and get rid of them. And then if there are extra instances around, if we pass them, if there are like instances that are basically just, they're going to be reaped or they're not reaped yet or something, and like they haven't become a node, and we give back a count that is higher than the actual number of instances that we see that are linked to nodes, then the cluster autoscaler thinks that there are still nodes that are provisioning or something. And so you can get into cases where you have, and this is kind of like this is different than what's happening in the bug I'm looking at, but you can get into cases where like a machine fails to become a node. And the problem we had originally was we kept reporting these failed machines or these machines that had not become nodes. And then the cluster autoscaler wouldn't react to new workloads that were coming in because it says, oh, I still have nodes that are coming online. I need to wait for these nodes. But these nodes never became nodes basically, right? And because they weren't getting deleted by the cluster autoscaler either, the machines were just hanging out there, and they would never, and the cluster autoscaler would get locked basically.
Okay. So I don't know if it works out entirely, but in my mind, it would not be the job. So I think it would be correct that the autoscaler reports machines. So that it detects machines is like they're still coming up, but I think it should not necessarily be the job of the autoscaler to delete those machines. What I would expect is that someone configures a machine health check where we have configuration specifically for that. And that configuration triggers copy to delete the machine and create a new machine.
Well, I mean,
So
like,
basically-
but like this is where like you've told the cluster autoscaler manage this machine deployment for me, right? And so now the cluster autoscaler is going to manage the scaling of it. And if you
Yeah, but I mean, the autoscaler is saying like, oh, I want to scale up, right? And then if you have copy, a machine deployment, and a machine have check, then basically that combination would lead to the result of getting enough machines, right? Because machine deployment controller tries to scale up, and machine have check controller gets rid of stuff that is not coming up and will retry the creation.
Well, yeah, I
Actually.
mean, if you're running the machine health check, yeah.
Yeah, if you're not using machine health checks, then I mean, what we're basically talking about is re-implementing the machine health check in the autoscaler, right?
Well, no, because we don't want to check the health of the machines. We just want to say like because the cluster autoscaler has a setting for how long it should wait before a machine becomes a node, right? And if the machine never becomes a node in that time, then it wants to delete that machine.
Okay, so you're talking about re-implementing the node startup timeout configuration property of the machine
I
health
mean,
check.
that's already in the cluster autoscaler. That's already part of the cluster autoscaler, right?
So
we just
but maybe that's an approach that makes sense if people don't want to use machine health check with autoscaler, which is so the way that no, let me just explain and then sorry,
Okay,
don't
go ahead.
take this seriously. What I was thinking is like the way that the machine health check is dealing with that is basically so machine health check also does not react on failure message anymore because failure message is not a thing anymore. But machine health check has something that does something similar than what you want to achieve. And what that is basically that on a machine health check you can say wait an hour for a machine to come up, and if it doesn't come up after an hour, then it triggers remediation. And what it's using for that is it also has a property that says like wait that 1 hour, similar to your provisioning timeout, same config. And the way that the machine health check controller detects that is basically comparing creation timestamps with that duration, and it's saying like, okay, if there is a machine that was created more than an hour ago, but we still don't have a node for it, then something went wrong. Let's get rid of it. And I think that same concept could also work for you, right? That you basically have a configuration property, whatever provisioning timeout you have, and then you say, if you have a machine that is that old, but you still don't have a node for it, let's get rid of it. So it's really more like duration based than you have a specific failure that you can point at.
Yeah.
But you already have a timeout for that, right? So you already have the timeout property.
Right. And like, so now I'm thinking like, maybe we just need to remove all this. We just need to like not have.
So it's like the timeout handling basically below.
Well, then this is where it's it's trying to detect pending machines. Like this was all modeled after the way cluster API used to be, I guess, like trying to follow the machines through the different states so that we could report to the core of the autoscaler. It would know what, where those instances were, and it could say, okay, this instance is still becoming a node. We need to keep an eye on it because if it never becomes a node within the time the user has asked for, then we need to get rid of it and make a new one or something, depending on what's happening. So these are like features that are exposed in the cluster autoscaler, that like users are kind of depending on there, I guess.
Yeah. Okay. So basically what you have by having this failure message on top of that is that on top of reacting to the timeout, you can also react on someone is reporting maybe quicker than the timeout.
Well, right.
This will never provision, right? That's like additional benefit you get.
Right.
If the status failure message thing exists.
Right. And we want to not include these nodes. We want to not include these machines in the count because we want them to go away eventually, right? We want to make sure the autoscaler is making machines that are appropriate for it. Okay, so I mean, it sounds like I need to re-examine this whole thing.
So just from my understanding, you're doing two things. On one side, you're not counting it. On the other side, you also get rid of this, right? If you have the failure message set.
Right. Like what? Yeah, I mean, this is like, it gets really.
Or are you also not counting it and then the machine stays around?
Well, no, like, so what happens is when we go through this, we run through the list of machines and then internally we modify the provider IDs to have like they're prepended with information that we can use to know what state it is. And the reason we do that is so that we can pass it back and forth through the core of the autoscaler and still keep track of like what we're talking about, because the autoscaler core doesn't allow us to pass like extra cluster API information through it. We can pass like, the provider ID, and we can pass like the node group information associated with it. So in this part of the autoscaler, we look at the machines that are all in the node group, and we try to figure out like what state they're in so that we can give better information back to the core of the autoscaler and I don't think it's in this part, but there's like a structure that we pass back where we try to tell it the state of each instance so that it can then make decisions around what it wants to do based on where it sees, is this instance still becoming a node? Has it failed to become a node? Is it, has it not even started to become a node yet? So like it wants to try and manage some of these things internally.
Okay, and I assume this failed thingy basically will eventually lead to a deletion. in some other part of the controller, right? Because you
Right,
probably
like-
you probably don't collect the failed machines and just keep them.
Right. I mean, yeah, we don't keep them around. Yeah, exactly. Like, a machine in a failed state, like for this part where we're trying to find the resource provider IDs, like I said, this logic used to be a little different and it got improved because someone had made a contribution to try and take advantage of this extra information we could give to the core around what state these instances are in. But I think I'm going to have to go back and just like reconsider this whole thing and how it works.
Yeah. But just maybe like on a high level, coming back to your original point. So, I mean, while basically this field existed in the past to detect this kind of information, today there is no concept like that anymore.
Right.
So we have conditions, we shuffle. So basically, the thing that we have today is that you can set conditions on various places and then they end up in a machine. And then if you have an MHC, you can use those. Basically, it's so the way it works with MHC is you do something on infra machine, it bubbles up to the machine, then maybe machine becomes unavailable. And then if you configure your MHC accordingly, that if this machine is unavailable for an hour, delete it, then you end up with a deletion. So basically, it's like two pieces now. On one side, condition reporting, on the other side, user configuration in an MHC to basically make the call, is this a failed, should this machine be deleted or not? So we have like more config basically to express the same thing that we had in the past.
Yeah.
And to basically also make it user configurable, what exactly they want, after which timeouts they want. And
So-
to say, like, in which case exactly something is. So failed basically means unrecoverable, right?
Right.
In that sense. Yeah.
But like, it sounds like the concept now is not failed. The concept is you tell Cluster API a time period for which you expect, or the machine health check, you would be advised to say, okay, I expect nodes to arrive within some amount of time. And if they never arrive, if they never become nodes in that amount of time, then that means they need to be remediated. And so it sounds like we need to do like this. I'm looking at this because what would happen, like if a node isn't failed, right? Like meaning it's still attempting to provision, it doesn't have a provider ID yet, right? Or maybe, like, I guess this is the thing, if it has a provider ID but doesn't have a node reference yet or something, like it's failed to actually become a node or whatever. And I think maybe we need to let this drop through and like, okay, if it doesn't find a provider ID, let it behave as if it had no provider ID. And if it doesn't find a node reference, just let it behave as if it doesn't have a node reference. And in this respect, we don't have a failed machine, but we just let the cluster autoscaler time it out because presumably that's what the user wants, right? Like this machine did not become a node within the 10 minutes or 15 minutes that you expected. The autoscaler is just going to remediate it the same way the machine health check would.
Exactly. I think the only thing you're losing is that if it would have been reported quicker that it's a failure, that
Right.
it would have been deleted quicker. That's the only
Right.
thing that's different.
And that was what we were trying to detect here originally, which was like, yeah, okay, if you tried to get an instance and like okay, let's say I'm using cluster API, I try to increase replicas, but there's not enough quota in the region or whatever to give me an instance, right?
Yep.
So like what happens in that case? Like I've increased replica count to 1. It tries to make a machine, but the machine can't deliver an instance to me. So what state is that machine in? Well, like how would I know?
So if you talk about a phase, it should be provisioning and conditions. It slightly depends on what the infra controller reports, but I would
But
basically expect that. Let me check. Sorry,
I
the
shouldn't
infrastructure
rely
ready
on that phase though, right? Or I just shouldn't rely
No,
on
no.
phase failing.
I'm just explaining to you how the machine looks.
Oh,
I'm not
okay,
saying you
okay.
should look at
Sorry,
phase.
sorry. Apologies. Sorry.
All good. I'm just saying, like on a machine, basically, what you will probably see that the phase is provisioning.
Right.
The infrastructure ready condition should be false, and ready and available condition should also be false because they're including infrastructure ready in their computation. So that's what I would expect.
Okay.
But also just to mention it, like this previous behavior here, like, right, you get the failure message and then you delete directly. That also has a huge downside. Potentially, depending on what other config you have. I mean, I don't know how quickly you will recreate machines or if you have some other properties that are sort of mitigating like 1 million machine creations in an hour.
Right.
Probably there is something in the autoscaler as well, right, that makes sure that this doesn't just very, very quickly creates a ton of machines and create fail.
Right. It has that concept that if you tell it a machine failed to be created, like if you tell it errored out before the timeout happened, it can
Yeah.
put that node group into back off and stuff like that. So yeah, it
Okay,
has
okay,
concepts
okay,
like that.
okay,
Yeah.
good, good. Alrighty, so that would have been fine. Yeah.
Okay. I clearly have more research to do, but this has been illuminating. Thank you, Stefan and Fabrizio. Okay. I'm guessing nobody else has questions about this. All right. Wei Chen and Cody, you've got a new proposal of independent worker. So yeah, turn the mic over to you.
Thank you, Michael. So this is a new one-pager proposal to replace the previous Google Doc proposal. It has too many pages, so this is a much shorter and a concise version just for the work. So we've done some prerequisite work, and those prerequisite works are ready right now. And we are working on the next step, which is to add a feature flag and to actually implement these new features. So for people who don't know about this, in one sentence, this is to allow the Capi clusters to have when you have the topology managed Capi cluster, we allow you to have independent machine deployments or machine pool. They can stay the version they are instead of getting managed and upgraded to the major topology template. So please give us feedback and take a review of this proposal, and we will have our next work group meeting next Thursday. That's it. Thank you.
Cool. Thank you. Does anybody have questions or comments about this? And you said there'll be a meeting next Thursday. Is that what you said?
Yes. The meeting is the same link as this one.
It's in this channel.
Yes.
Fabrizio, you've got your hand up.
Yeah, I just wanted to bring up that there was huge work to get to this current point. We are really trimming down to the minimal viable option. And it seems, yeah, I still have to read the proposal, but we discussed basically the content. I think this is really interesting to have. So please take a look. Let's consider that this is a first iteration. So we are sort of saying either the users let cluster API and topology manage all the machine deployment, or you take responsibility. And that's the simplest, and eventually you will be able to, and you can pin your machine deployment or eventually bring it back to the same level of the cluster, and cluster API can take over. So at the end, this is a very complex problem, but we did, and congratulations and kudos to the team. We really nailed it down to something that is good enough and simple enough to understand and start experiences on this. So please take a look.
So I have a question, and I have to apologize. I have not been up to date on the independent worker apology, but given what you just said, it makes me curious. Is this something that we might want to consider changing the design of our Carpenter provider around? Because Carpenter wants to do its own management of instances. And I had looked at designs way back in the day about making what we called like orphan machines or whatever. And I'm just wondering, like, I mean, I know the answer to this is Mike, go read the proposal, but I just thought I'd bring it up here because it just occurred to me while you were talking, Fabrizio.
I think this is a different problem. So
Okay.
let me say what we are facing both for autoscaler Carpenter API is that there is not a clear definition of who is responsible of what. Okay, and what we end up is that Cluster API is an autonomous project and tries to be a solution that cover most of the cases. So it provides drains, it provides a way to manage version, etc., ways to handle healthiness, etc. Okay. Then we have these other projects that, of course, were designed not with Cluster API in mind. Okay, and they solve the same problems. Okay, now we get to a point where we try to bring them together, and of course, we have to when you make this integration both for the autoscaler or for the others, you have to pick one that is responsible, because if you have two, then it is confusing. So what we are discussing now is this proposal is about Cluster API, topology manager, taking care of the life cycle of the machines. Okay. If you talk about Carpenter, so when we discussed we discussed a couple of options. One was, we give Carpenter standalone machine. It basically takes care of it, and it replaces this idea of machine deployment. It's just using the machine CR of copy and do whatever it is. But we didn't like it, because if you do this, you are basically giving up most of copy. So,
right. Yeah, exactly.
And so, and this is the same why we are telling, hey, autoscaler, who is responsible for drain? Because copy has its version of drain, which is quite sophisticated, not drain rule, etc. What we do here. So I think those are integration problems that goes to bringing together products, the project that somehow overlap, and we have to define single responsibility. This proposal is clearly, it is part of copy, is not assumes that copy topology manager is responsible of the node pool, and it is version management. So if you think to use Carpenter to do upgrades, is not covered by it. It is definitely out of scope of this proposal.
All right. Cool. Yeah, I appreciate the quick feedback, but I will go read it too, just because I'm curious. Thanks. All right. Does anybody else have questions about the new independent worker proposal? Okay.
Just a note, this is going to be an experimental feature. So we have a feature flag to protect it. And also we design to allow users to switch back if you want to get your machine pool or machine deployment back to be managed by the topology. And we will also, after the proposal is reviewed, we will also provide more feature information and update the TEPI book to include details about this feature.
Sounds cool. All right. Anything else we should cover on that topic? Okay, I'm not seeing any hands going up or people are muting. We got no provider or feature group updates, so I guess we'll end a little early unless folks have anything they want to bring up at the last minute here. Going once? Going twice? Okay, sold. Thanks for coming out, everybody, and have a great weekend. We'll see you next week.
Thank you.